At this point, you're probably realizing that the more bits you have per pixel, the more colors that you can produce. So what I'm going to do right now is I'm going to up this to 12 bits per pixel. And notice that my picture gets a little funny. So I'm going to go ahead and delete that. And I'm going to go ahead and I'm going to be, okay, so if I have 12 bits per pixel, that means I have 4 bits controlling red, 4 bits controlling green, and 4 bits controlling blue. So let me turn all my red lights on, and my green and blue lights off. Okay, so this is the same red that we've seen before. Now if I want to look at different combinations, I can. Okay, so you can see that typing all these ones and zeros is going to get to be a lot. So what we can do is we can use a different system to tell a computer what colors we want to produce in each pixel. And that system is called the hexadecimal system. So what I'm going to do is I'm going to click this text box. And notice what happens. All of a sudden, I have F00, 0, and then an 8, and then 2 zeros. That seems kind of strange. Well, here's what's going on. The F, see that right here, the F, is representing 4 ones. And those were the 4 red lights that we turned on. The zeros, basically nothing's going on there. Okay, so that would just be a 0 would be the equivalent of 4 zeros in binary. Okay. And then see this right here, 800. Well, in the hexadecimal number system, 8 is 1 1 with 3 zeros afterwards. So I could use this little table to convert between binary and hexadecimal, and then I don't have to type quite so much. So let's do something like, okay, what if I want a less bright yellow, or a less bright red? Maybe I could do something like, I saw an A on the table. Let's see what happens if I do an A and 2 zeros. Oh. Let's see. You could do a 1. I saw on the table. Oh, okay, that's okay. Okay, let's see. How about a B? Ah, C. Oh, now I'm getting a lot of different colors. This is pretty cool, right? So I can get a lot more sensitivity with my colors and not have to type quite so much. Now, professionals use all the way up to, get ready for this, 24 bits to describe a color. Crazy, huh? That way you can be super specific. Super specific. If you have 24 bits per pixel, what that means is you have 8 bits representing each color. So, for example, this F00800 would represent my first box. That would be my first pixel. And what you can think about is you can think about, okay, if I converted this to binary, this right here, these, if I have 8 binary numbers, 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I just need to put some spaces in here. So I was trying to figure out which were my first 8 numbers that were representing red here. Okay, so here's my first 8 binary digits, which show that the first 4 red lights are turned on, and the next 4 red lights are turned off, and this is, I'm getting this nice red color, and what I want to tell you is that to control red, the biggest number that I can put in here is 225. So 1 1 1 1 1 1 1 1. would represent the decimal number 225. So oftentimes you're going to hear of color intensities that range between 0 and 225, and the reason why is because each color is described using 8 bits. Okay, that's it for this video. Good luck.